Oh, and welcome to the oro-oto-cerebral pathway. In systemic embryology, cardiovascular system, today we are going to talk about septum formation in truncus arteriosus and conus cordis. To briefly set the background, we have the cardiac tube on day 23, which started folding or looping, and in the process of next 5 days, the straight looking cardiac tube with 4 dilatations, the bulbus cordis, the ventricle, the atrium, and the sinus venosus, assumes a S-shape form and looks very much similar to the definitive heart that is yet to form, but the external silhouette starts kind of matching up. During looping, the bulboventricular part of the cardiac tube actually moves downwards to the right and forwards, and the venous end of the heart containing sinus venosus and atria move in the opposite direction, that is cranialwards to the left and posteriorly. Though the looping is almost complete by day 28, still realignment of primitive chambers of heart is yet to be completed. So this is what we are going to begin with this particular episode: realignment of primitive chambers of the heart. The atrioventricular canal only provide direct access between the future atrium and future left ventricle. Cardiac looping, chamber expansion, and realignment must occur to bring the developing atrioventricular canal into alignment with right atrium and ventricle, and also to provide the left ventricle with a direct path to the outflow tract. AV canal alignment may be accomplished by active remodeling of the dorsal bulboventricular sulcus that involves cushion cells being invaded and replaced by myocardial cells, and these myocardial cells later show apoptosis. In addition to that, shortening of the outflow tract due to apoptotic death of myocardial tunic at distal end of the outflow tract generates torsional forces that rotate the outflow tract and position it over the atrioventricular canal. So when we have these separation and communication channels correctly aligned with each other, now the cardiac chambers can actually start the septum formation in order to get the 4 definitive chambers, the 2 atria, the 2 ventricles, and the outflow tract of both the ventricles will be aligned with the respective cavities of the ventricles, as well as their efferent channels in the form of the ascending aorta and pulmonary trunk can correctly form with the appropriate natural normal alignment. In the 5th week, pairs of opposing ridges appear in the truncus arteriosus. One is on the right superior wall and the other one is on the left inferior wall. Now here, picture this as if we are talking about a trumpet. The lead pipe end of the trumpet is closer cranially and the bell region is caudally placed or caudally directed. Now here, right superior truncus swelling or endocardial cushion appears on the right superior wall at the end which is closer to you, that is the lead pipe end, and at the very same lead pipe end we have the left inferior wall where the left inferior truncus swelling develops. The right superior truncus swelling starts growing, and the direction of growth of the right superior truncus swelling is towards left. So when it grows, and as you trace it from the lead pipe region of your trumpet towards the bell, the path of journey would be, it starts from the right superior area of the narrowed end of the outflow region of the heart tube, and it then progressively passes in front, that is anteriorwards, and then goes on towards the left side, which describes the direction of growth of this swelling. The right superior truncus swelling grows to the left. When this is happening, at the same time, the left inferior truncus swelling is growing to the right, following the similar path but in opposite direction. So from left inferior region, it is first turning backwards and then gradually moving towards right in a continuous streak-like manner. So when the right and the left truncus swellings reach their destination, they twist around each other while growing towards the aortic sac, and that divides the outflow tract into two equal parts, but they are not oriented vertically or horizontally, rather they are oriented in a twisted manner with each other. The two swellings which we just spoke about fuse to form the aorticopulmonary septum, or because of the nature it is also called spiral septum, and the septum divides the truncus arteriosus into an aorta and a pulmonary trunk. Similar swellings, that is right dorsal and left ventral conus swellings, appear in the conus cordis. These fuse with each other and the spiral septum to form collectively the cono-truncal septum, which is a spiral and it extends from the conus cordis onto the truncus arteriosus, dividing not only the outflow tract of both the ventricles but also the efferent channels emanating from the respective ventricle in the form of aorta and pulmonary trunk. The conus is divided into two portions, the outflow tract of the right ventricle and the outflow tract of the left ventricle. The spiral course of the cono-truncal septum explains the adult relationship of the aorta and the pulmonary trunk to each other. It is important to note that a significant contribution for development of this spiral septum comes from the neural crest cells. The neural crest cells migrate along the pharyngeal arches 3, 4 and 6 from the region of hindbrain towards the developing heart tube, and there they contribute to endocardial cushion formation and also contribute to the formation of the semilunar valves. So this is how the aorticopulmonary septum or spiral septum forms and separates not only the bulbus cordis but the truncus arteriosus also. By separating the bulbus cordis, it develops the outflow tract of both the ventricles, and by making the septum in truncus arteriosus, it divides the aorta from the pulmonary trunk with their correct alignment with respective outflow tracts of the ventricles. Let's just see something about the clinical anatomy of this. If there is an abnormal neural crest cell migration, the resultant would be only partial development of the aorticopulmonary septum, leading to persistent truncus arteriosus. The persistent truncus arteriosus results in a condition in which one large vessel leaves the heart and receives blood from both right and left ventricles. The persistent truncus arteriosus is usually accompanied by a membranous ventricular septal defect and is associated with marked cyanosis. In the next scenario, abnormal neural crest migration towards the developing heart tube such that there is non-spiral development of the aorticopulmonary septum would lead to a dextrotransposition of the great arteries. This results in a condition in which the aorta arises abnormally from the right ventricle and the pulmonary trunk arises abnormally from the left ventricle. Hence, the systemic and pulmonary circulations are completely separated from each other. Such a situation is incompatible with life unless an accompanying shunt exists like a ventricular septal defect. In yet another condition, the levotransposition of great vessels, the aorta and pulmonary trunk are transposed and the ventricles are inverted, such that anatomical right ventricle lies on the left side and anatomical left ventricle lies on the right. These two major deviations offset one another such that blood flow pattern is normal. And then there is a tetralogy of Fallot. This is caused by an abnormal neural crest migration such that there is skewed development of the aorticopulmonary septum. The tetralogy of Fallot results in a condition in which the pulmonary trunk obtains a small diameter and the aorta obtains a larger diameter. Tetralogy of Fallot is characterized by four classic malformations: pulmonary stenosis, right ventricular hypertrophy, overriding aorta, and ventricular septal defect, giving rise to the mnemonic PROVE, prove. Well, that's all you got to know about the development of aorticopulmonary septum and its relevant clinical anatomy. Happy learning!